Text mining in R with Supreme Court opinions, part 5. Okay, once again, here is the GitHub repository where you can get the code and the data for this illustration. You can download the entire project and you can run it with me as I work through this if you would like. Now we're going to move on to something that I think is a little bit more interesting, and that's we're going to get all of the opinions for a particular justice. And when I say all, first of all, it's important to note that I mean all of the PDFs that I have downloaded, which is only 10. And there are a lot more. If you go to the supremecourt.gov site that we were on earlier and look at the 2019 session, there are lots and lots and lots and lots of cases. And I've downloaded 10 of them because I think that's a sufficient number to kind of demonstrate this in a context that's non-trivial, but it's not so overwhelming that it would take forever. If you wanted to, you could simply follow the steps in this tutorial here, and you could just download more PDFs and just add them to the data directory. I will warn you guys, this part might get a little bit gnarly because I'm kind of going to be throwing in a crash course in like some functional programming stuff. I think I can make it work, but I'm kind of just keeping my fingers crossed at the moment. So what I'm going to do right now is I want you guys to note that I am in a .r script, and this script is in the project directory, and it is in the GitHub repository. So if you go to the GitHub repository for this text mining vignette, inside the R directory, you will find this functions file, and that's the script that I've been pulling a lot of this code off of to do the single opinion case. Okay, right now I'm going to switch over and start pulling code off of a markdown document that is also in the GitHub repository, and it's this markdown text mining with Supreme Court Supreme Court opinions. Okay, and we're going to go through how to do this word count that I showed at the very beginning for all of the opinions. Again, all of the opinions, meaning all 10 of these cases. And anytime Chief Justice John Roberts wrote either a majority or a dissenting opinion in any of these 10 cases, that's what we're going to be harvesting here in this step. And so the first thing that I want you guys to take note of is that I mentioned this sort of briefly in passing, and in an earlier step I said I didn't want you to get too hung up on it, but now we're going to have to get hung up on it a little bit, which is get markers is a function, and it's a function of an input called case. Okay, I'm going to run this function, and once I've run this function, we're going to see that it's available to me. Get markers is a function. It's a function of case, and so if I do get markers and I give it one of these cases, it's gonna spit out that get markers data frame. It's gonna spit out that info data frame, which has the information. And a lot of what I've written, all of what I've written here in this particular script is a set of functions. It's a set of functions to do things, because when I'm moving from doing this analysis from a single PDF to 10 of these PDFs, I want to just be able to call functions that make things happen easily. So a few of the other convenience functions I've written get case text. So get markers is going to get me a list of the opinions and the locations inside the documents where those opinions are. Get case text is just a a convenience function that I wrote that's going to take a case and it's going to pull the text from that particular case. And I promise that I'll be very clear about why this is useful when I start pulling the text. Right now, I just want to introduce you to the fact that this is a function. I have another function called getJusticeOpinions. It's a function of a justice and a case list. And so this is a function where I can feed it a justice name, and it will use the information from markers, and it will use some other functionalities to get the text associated with opinions written by a particular justice. Have some other convenience functions here. Filter case text, which is going to accept as an input case and a page range. So again, it's information that will come from the output from this getMarkers function, and the output from this getMarkers function can be passed into some of these other functions to do things like retrieve text between a page range, such as I might want to do if I were looking at getMarkers and I wanted to get the dissenting opinion from Clarence Thomas. I would use this convenience function. And the way that I'm going to make those functions available, let's do this first. Rm list equals ls, right? Our familiar workspace clearing mechanism. I'm going to clear everything out so we're in an empty workspace, and I'm going to go through this markdown document. Again, I've got some libraries that need to be loaded, some packages that need to be loaded, so I'm going to load those up. I have a case list, so all of these cases here that I've downloaded and saved into the data directory, I'm going to create an object for them. I'm going to create a list so that I can iterate through these easily. And now this is the functions part. So I'm going to use this method here called source. And when I use source, I'm going to pass source the location of an R script. That's this R script here, which contains all these functions. Okay, so when I source, notice in the global environment, there's only one thing right now. Okay, there's case list. Only read one thing into the global environment. When I source this R script here, now all of the functions from this script, okay, that I just went over, all those functions are available to me now in my workspace. So notably, getMarkers, right, as a function of case is now available to me, and I can see that here in my global environment. Okay. So with these functions, let's go ahead and look at the getMarkers. And so what I'm going to do here in this step is this lapply method. Again, this should be, or at least it should be starting to become kind of familiar. I'm going to apply the case lists, so the cases in the case list object, right? Case list has the names of all of these PDFs that I downloaded into the data directory, and I'm going to send all those names to the getMarkers function. And if you recall from the exercise that we just did with a single opinion, we got a data frame back that had 3 rows because that particular opinion had a majority, or that particular case, had a majority opinion and 2 dissenting opinions. And so that information came back to us in the form of a data frame with 3 rows. Now I'm going to send all of the cases to that getMarkers function. And so I'm going to get back a much bigger data frame. Okay, so let's execute this, and it'll print out the markers. So this is that getMarkers function, and when I send it all of the cases, all the PDF files that I've downloaded to this directory, it returns to me this pretty big data frame, which has the locations of the dissenting and the majority opinions in each of these documents. And so this is kind of the lookup table, as I've been calling it, that I'm going to use in this example where I'm going to get all of the opinions. So I'm going to skip down here to get all opinions, and what I'm going to do here is I'm going to get all of the opinions for Chief Justice John Roberts. So anytime Chief Justice John Roberts wrote either a majority or a dissenting opinion in any of these 10 cases, I'm going to extract that text and save it to a data frame. I'm doing this in a stepwise process here where I do the dissenting opinions first, and I'll go through that function here. It's another one of these functions that I've written and put inside of this R script that we sourced. So let me run that, and then we'll toggle over and we'll walk through the function itself. CJR, dissenting opinions, it's going to accept as arguments markers. So markers is this big data frame here with kind of the meta information on where these things are located inside of each of these documents. Okay. And let's take a look at what the object CJR dissenting opinions looks like. I can see from here it's a list of 2, and each of these lists is a data frame, and these data frames combine the words, so these are the tokenized versions of the text. And let's go ahead and toggle over to our functions, and let's look. Okay, so I'm back in this SLIP 2019 analysis functions.r script where my functions live, and I'm looking for the function that we just executed over here on the RMD, which is justice.opinions. So I'm going to scroll down, and I have the function justice.opinions here. It's a function that accepts 3 inputs: markers, justice, and type. So markers is, again, that data frame with the lookup information. Justice is the name of the justice that I want the opinions from, and type is the type of opinion, majority opinion or dissenting opinion, that I want to extract. And the first thing that happens in this, so let me set some values for this function, and we'll walk through what it does. Okay, markers, if I look up here, markers is an object that's already in the workspace, so that's fine. Justice is not something that has a value yet, so let's give justice a value. Let's give it the value John Roberts. And type should be, so here I've commented, I've left extensive code comments on how this function should be used, and if I scroll up here I can see that type should take the string values majority or dissent. So let's set type to be dissent. Okay, if we do that, the first line in this function is going to set up a temporary data frame, and it's just going to filter the markers data frame for the justice and the opinion type that we're looking for. So if I look at temp now is the filtered version of this markers data frame, which has all of the dissenting opinions from the markers data frame that were authored by John Roberts. And the next thing I'm doing is executing a loop. So with a loop, I need something to hold the values in. So I'm going to declare an object called justice.opinion.words to be an empty list, and that empty list is going to be populated as we move through the loop. The loop is going to go from 1 to n row temp, which means it's going to iterate through the values in this temporary data frame. N row is 2, so it's going to go from 1, it's going to execute from 1 to 2. And the first thing it's going to do is get text. So the text that it's going to get comes from another convenience function called filter.case.text. And that's a function that I've written that accepts a value for case. In this case, it's going to take the case column from the temp data frame for whatever iteration we're in. So for I, if I equals 1, then case is going to equal temp case 1, which is going to be this PDF file, and the page range is going to be the page range from the temp data frame for the first row. And so if I do this, it's going to get me, again, markers, tells me row by row the location of the dissenting opinions for John Roberts for any of the cases here for which John Roberts authored a dissenting opinion. This is going to get the actual text of that dissenting opinion. And so we've grabbed a big blob of text, and then this unnest tokens method that we demonstrated earlier, I've wrapped that in a function called tokenize case text. So I can send the text to this function, and this function will take that text and we'll do this unnest tokens method on it, and it will return the tokenized data frame for that text. Okay, so we have the text. If we do that, then let's see, head df, right? We have this familiar data frame, which is the words. Each word is a row in a data frame, so all of the text from that dissenting opinion has been broken up into words and stored in a data frame. This last line here is going to take this empty list that I declared outside of the loop, and it's going to put that data frame inside an element of that list. Okay, so if we do that, justice opinion words 1, we've populated that empty list with the words from that particular dissenting opinion for this case and for Justice John Roberts. And so because this is a function, as we noted, there are 2 rows. That's a little cumbersome. Let's go back over here and show that there were 2 rows to this temp data frame. And because there were 2 rows in this temp data frame, there are 2 rows, 2 list objects, CJR dissenting opinions, is a list of 2. It's a list of 2. Each of these list objects is a data frame. Each of these data frames contains the words that are in each of two dissenting opinions that Chief Justice John Roberts wrote. And by now you guys are probably pretty sick of seeing R bind lists and L applies, but I've got another one for you because the CJR dissenting opinions object is a list of data frames, and I want it to be a single data frame, so I'm going to R bind list that list object and then coerce it to a data frame so that I have the words from the dissenting opinions from Chief Justice John Roberts in a single data frame and nicely organized. The next thing that's going to happen is that I'm going to repeat the step that I just did up here, and I'm just going to change one value. I'm going to change the type to majority. Sure, I could have written my convenience function to not accept the input type, and maybe that would have been a little easier. I could have just harvested all of the text and then parsed it into words from any opinion from Chief Justice John Roberts. And that's something that you guys could do if you wanted to amend this for your own purposes. It made sense to me to do it, and I felt like doing it this way, so I did. And it adds another step, but I don't mind that much. I run this step, and I get the majority opinions. And again, I get the data frame with the words. Each word is a row from any of these cases where Chief Justice John Roberts wrote the majority opinion. Now, the fun part, doing the word counts. So for this word count, again, I have two data frames. I have one for the dissenting, one for the words contained in the dissenting opinions, one for the words contained in the majority opinion. And I'm going to take the stop words out. So this is something that I mentioned in a prior step. There is another functionality contained within the tidy text package, and that is this stop words dictionary. And using this stop words dictionary and this anti-join method, I can take out all of the stop words, and that's something that I gather anyway, people who do text analysis a lot like to take out stop words because they're uninformative and they're going to be in every text written pretty much anywhere. So they're not considered terribly informative, and people seem to like to take them out. Again, this is not my area. I claim no domain expertise in text mining. I'm just copying what I've seen other people do, and I'm trying to demonstrate how it can be done in R. If any of you who are the real pros in this type of thing want to do this in R, data stop words will bring that stop words dictionary into the workspace, and then these two lines here will simply filter the dissenting opinions data frame and the majority opinions data frame to remove those stop words. Okay. And now what I can do is sort these data frames and count the words. So similar to the dplyr methods that I use, the syntax is just a little bit different here, but I'm going to just count them up, and I'm going to sort them according to the most frequently used words. So if we look at those objects here, one, I have word count dissent. Let's just look at head. I have a sorted word count for all of the words used in the dissenting opinions written by John Roberts and the number of times those words occurred. We can similarly look at the data frame for the majority opinion. And have a similar data frame. What I've done for the plot then is, okay, I'm R binding these two data frames. So again, I know that this seems strange to declare two different data frames, carry them both around, and then join them together later. I could have I could have joined them together up here and just not carried around two different data frames in my code. But I thought for illustrative purposes, this was a better way to do it. It probably is not the most efficient way to do it. But I'm going to R-bind these two data frames, and then I'm going to group by the opinion, and then I'm going to filter out anything sort of anything outside of the top 25. Just, there's no reason for that. I'm just going to do it so that I can look at it and then plot it, and I've arbitrarily chosen the top 25 words. You could arbitrarily choose a different cutoff point. But one thing that I thought was kind of interesting is grouping by the opinion. I thought it might be useful if one were interested in this sort of thing, like looking at the text and the words used by justices in their Supreme Court opinions, to stratify those opinions by dissenting opinions and majority opinions. I don't have a good compelling reason why that would be interesting. It's just a dimension of the data that we can partition on, so I did it to illustrate that it can be done. And so this is our end result. This is a word count. And what I want to show you here is that I've presented it this way. And one of the advantages of presenting it this particular way, which retains all of the words, whether they were used in the dissenting opinion data frame or not, is that you can see which words appeared in one of these types of opinions, but not the other type of opinion. So I think that can sometimes be informative, but I will show you that if you wanted to have a cleaner aesthetic to something like this, what you could add here is another line in the ggplot command, which is when you do facet wrap, you can add an option so that your facets scales equal free will allow you to have a different scale for each of your facets. So it won't show you the same words across these two partitions, but it will give you a slightly cleaner aesthetic if you only want to see the words that were present in the majority data frame and only the words that were present in the dissent data frame.